So, because there's kind of 5 different types of properties that we'll be dealing with exponents. So we've already seen these. So let's talk about our shortcuts here. So if I were going to do this problem right here, I would split it into 2 kind of pieces. The first piece is I would look at my coefficients, this 2 and this 2. I'd multiply them together and I would get 4. So go ahead and bring a 4 into your answer. And then we're going to have some n's also. And what is the shortcut for these exponents? What are we going to do with this 2 and this 3 and this 3? We're going to add them together. 2 plus 3 plus 3 is 8. So the shortcut is when we are multiplying, we have a product, we're multiplying a bunch of stuff together, we add the exponents. That's our shortcut here. So let's see if we can tackle number 2 together. First thing I'm going to do is like all of my variables there. I'm going to tackle the coefficients first and then we'll do the x's and the y's. Which one do you want to do first, the x's or the y's? The x's? All right, so my answer is going to have an x. So look at your x's. You've got an x to the second and an x to the fourth. What are we going to do with the 2 and the 4? Add them up, and we're going to get 6. So we're going to have x to the 6. We're going to have some y's also. We're going to have a y to the first, a y to the third, and a y to the fourth. We're going to add those exponents up. 1 and 3 and 4 add up to 8. 4x to the 6, y to the. I think let's get some notes into our packet. You've got a page that's got some kind of grid paper on it. It says laws of exponents or exponent rules. So let's write down some exponent rules here. We'll just write down a couple of shortcuts. So here's our product rule. We have a product for that. The exponents. And the exponents. So I'm going to give myself some examples. Let's do x times x. So give me some exponents. 10 and 4. 10 and 4. So if I did x to the 10th times x to the 4th, my answer would be x to the 14th. And I'm going to make myself a little thought bubble here. Where did that 14 come from? And 10 plus. All right. So sometimes we add this. All right, let's go back to our sheet. Next 2 examples, power property of exponents. This is when you've got a parentheses of the power inside and outside. For number 3 here, do me a favor. Let's put an exponent on this 3 here. What exponent goes on anything? 1. What's the shortcut here? What are we going to do with our exponents in this situation? We're going to multiply. So the shortcut here is multiply. So my answer is going to have a 3 in it and an n in it. We just have to figure out what powers they're going to be. So look at the exponent on the 3. It's 1. What am I going to multiply that by? Well, there's 3 on the outside. 1 times 3 is 3. And then the n had a 3 on the inside, 3 on the outside. We multiply those together. What are we going to get? 3 times 3 is 9. So we're almost done here. We know what 3 to the 3 is, though. If we don't, our calculator knows. What's 3 to the 3rd power? 27 and to the 9th would be our final answer. So let's get some notes in our packet on the power property. With the power property, we're going to multiply our exponents. This is going to happen when you have, typically when you have parentheses, the variable inside. I'm going to use x again. Give me a couple exponents to put on inside and outside here. 8 and 4. Or did you say 24? 24. We could do that. Let's keep it a little simple. We'll go with 4. 8 and 4. So if I were going to multiply, or if I were going to work this out, I'd multiply that 8 times 4, and I would get x to the, what's 8 times 4? 32. It's the 32. Here's my little thought bubble. 8 times 4 equals 32. Just remind. All right, going back to our sheet, see if you can do number 4 for me. This is also a power property. Don't forget to put a 1 on that 3 there. All these exponents on the inside are going to all multiply by 4. So I got 1 times 4, 2 times 4, 3 times 4. And 3 to the 4th, since there's no variable there, we should be able to get that. You can use a calculator if you like. What's 3 and 4 power? 81. Final answer. 81, you did 8, Z to the 12. All right, you guys are doing awesome. Let's keep it going. This next one, we've seen this. You guys already figured this out, I remember last Wednesday. So let's do this problem. First thing I'm going to look at is that 3 and 11. Can you think of any way to reduce 3 over 11? What goes into 3 and 11? Just 1, isn't it? So nothing reduces. So our answer is still going to have a 3 and an 11. Let's get that in there. And let's think about the m's. I don't want to have to write out all these m's, but if we did write them out and they started canceling, we're going to have how many left over? 2 top or bottom? 2 on the top. M to the second. What did you do with the 8 and 6 to come up with that 2? We subtract it. So with quotient property, we're going to subtract the exponent. Let's go ahead and do number 6 while we're here. I'm looking at that 4 and 3 and thinking, I don't think that doesn't simplify, does it? 4 over 3? All right, we'll leave the 4 and the 3 there. Now tell me about my x's. If I wrote them out and started canceling, how many am I going to have left over? 2 of them on the bottom? This one up here is going to cancel one of these. We'll have 2 left over on the bottom. Agreed? Where's the subtraction happening here? What? 3 minus what? 3 minus, oh, there is a 1 on there, isn't there? 3 minus 1 is 2. Good. Yeah. All right, what about my y's? If I canceled out some y's, how many am I going to have left over? 6 on the top? 8 minus 2 is 6. Yeah, we have 6 left over and they'd be on the top. There we go. Here's our answer. Oh, you guys are doing great with this. Okay. So let's write something down for this now. This one gets a little bit more complicated. I think I might do 2 examples for this, but let's do quotients. And for this one, we subtract the exponent. But we also have to ask ourselves, where are the leftovers? Where are the leftovers? Are they on the top or the bottom? So let's come up with a cool example for this one. We're going to have x on the top and the bottom. A couple exponents I can use for this one. 12 and something smaller. 12 and 6. So if I were going to do this, we'd be thinking I'm going to cancel 6 of these with 6 up there. How many am I going to have left over? 6, they'd be on the top. Nothing on the bottom, so that's a 1. So my final answer will be x to the 6. And my little thought bubble here would be 12 minus 6. Can we do another one with more x's on the bottom? Let's do another one. You guys put up with great examples today. Give me a couple more exponents. You want to put some coefficients in there? I love it. Give me a couple coefficients. 4 and 6. Ooh, I like that because we're going to be able to reduce those. Cool. How about exponents? Give me something that's good. We want more exponents on the bottom. 72. Okay. And how many on the top? Something less than 72. 7. All right, I'm going with 3. That's the first one I heard. 7's also great. 4 is great. You do you. We don't all have to say the same example, right? All right. So we're gonna have a couple things going on. So let's start writing our answer here. First thing we're gonna do is we're gonna simplify this fraction. 4 over 6. 4 and 6 are both divisible by 2. What's that going to get us? 2/3. So we're going to have a 2/3 in our final answer. And then definitely more x's on the bottom. So x to some power on the bottom. Plot bubble that tells us where that comes from. That's 72 minus. All right. There's our quotient rule. We're going to skip zeros for right now. Go back to your sheet. Let's talk negative exponents. So this is new. Some of you were asking about 20 on that second assignment. You didn't know this, so you weren't able to do number 20, but I got you covered. Okay. So check it out. Here's how this works. Don't miss this because this is our new thing today. Okay. All right. So negative exponents, they move to the other side of the fraction. Okay. Now this is not a fraction, but we can make this whole thing a fraction, can't we? What are we going to put on the bottom? 1. Let's stick a 1 down there. All right. Don't miss this. Oh, also, let's make sure everything has an exponent. What can I put on these 2's? All right. Put those ones on there. Now, anything with a negative exponent is going to move to the other side of the fraction bar. So right now, see this x up here with the -1? See how it's upstairs in the fraction? It's going to move on downstairs. Moving downstairs. And this x to the -2, it's upstairs right now, but it's going to go downstairs as well. It is. Yeah. So, all right, what do we got left on the top? I got a 2 left on the top. I got another 2 left on the top. And I got a y to the second left up there. Those all had positive exponents, so they didn't go anywhere. That x to the first, the -1, that went downstairs. So the 1's still down there. And then this x to the -1. Now, when they move, the negative exponents become positive. Okay? Negative becomes a positive when you move. So it moved downstairs, it became x to the +1. This moved downstairs, it became x to the +2. We are so close to finishing this example, my friends. Let's clean this up on the top. What is 2 times 2? 4. So we got 4y squared on the top. We don't really need that 1 down there. How many x's altogether being multiplied down here? X to the 3rd, and that one's done. That's it. So negative exponents move to the other side of the house. And turn positive. All right, let's look at number 10. I'm thinking about doing a little canceling right off the bat here. What do you think? 6 and 6 are exactly the same. Let's cancel now. Oh, that's one mistake for you, Bill. All right. So what's staying and what's going? It looks like this Y up here is going to move downstairs. And then it looks like we got an X downstairs that's going to move on. So I'm going to do it in 2 steps. That's a great question. Are we going to add? Let's go ahead and just move stuff around first. So here's the X to the fourth that was already up here. Here's the Y to the fourth that was already downstairs. What moved up? This X to the fourth moved up. So now we got another X to the fourth up here. And then this Y to the third moved on down. So there it is downstairs. Then just ask the $1,000,000 question. Would we add that? Would we add these two fours together? Yep. Does that kind of look like what we had in our notes for when we added the exponents? Totally does. Yes, you're right. We would add them. So x to the fourth times x to the fourth, that's x to the 8. Y to the fourth times y to the third, add them together, 4 plus 3 is 7. All right, notes. You guys are doing great. I know this is a lot for like the day before Thanksgiving, but we got this. We got a break coming up. Negative exponents. We'll come back and do zero exponents. So how do you want to put this into words? I'm definitely gonna draw an example and have some arrows. I kind of like to have them in words too. How do you word that? Like the negative exponent go the opposite side and turn into a positive exponent. I'm trying to think of how I can abbreviate that so I'm not writing some words. Negative exponents. I like to put 2. Other side of fraction and positive. That's basically. So let's make ourselves up an example where we could just use. I think I might just go with. I don't know if that's an example that we could put in. Probably, I'm going to leave the 6 down. So let's. I'm just get this down. Ooh. Remember, you're making your notes, so you do whatever you want. Is that right? All right. All we have left to do is zero exponents, and I saved that for last because it's the easiest. Give me a universe. So let's talk about multiplication. When I multiply anything times 0, what do I get? Multiplication. What's 10 times 2? What's 10,000,000 times 2? Right? So you multiply times 0, you're going to get 0. Now, if you use something to the 0th power, I think it might be 0. So that's what we need to know about zero exponents. Let's write some notes down. Some examples. Zero exponents. Anything zero power. There's one exception to this. You cannot do zero to zero. That is undefined. So if I wanted to give some more concrete examples, I could say like 5 to the 0 is 1. X to the 0 is 1. I love putting problems like this on a test. -6, x to the 5th, y to the 78th, c to the 1652nd, all to the 0th power is equal to 1. All right, so let's do our last two examples here. Number 7. 2k to the 0 power is 1. That's the easy mistake to make, right? So you always got to double check yourself with that one. Now this one, there's only one thing that has a exponent of 0 here. It's the u. So that u to the 0, that would just turn into a 1. So basically, it's going to disappear. So I'm basically going to ignore it. I'm going to still have the 2 to the 1st. I'm still going to have the b to the 4th. And this will be a 3. But that's just a 1. You're multiplying by a 1. That doesn't change anything. And then we would finish this off using, what are we going to do here? That's add or multiply? Multiply. It's power to a power, so we're going to multiply. So we'll have a 2 and a b, 1 times 3, 4 times 3. And then I think we know what 2 to the 3rd power is. What's 2 to the 3rd power? 6, right? No, it's not 6. It's not 6. But I have made that mistake so many times in my life. All right. So, folks, I want you to finish up the next 10 problems on there. Not a whole lot of time, 10 minutes. I've got answers to them, so if you finish up, let me know and I'll let you check answers. We might need to fix a couple of things. Plan on making 1 or 2 mistakes here. That's good. That'll help you learn. Work on those. Ask me some questions, and then if you get finished, you may start on the back. We're going to talk about the back for about 10 minutes. We'll keep it short. All right, get after it. Let me know how I can help you.